Good morning, students. Today we'll study about the second order derivative, the topic from the differentiability from class 12th mathematics. Let's begin with, we have the topic that is differentiability, the chapter which we have started. Now we come to the topic that is second order derivative, that is second order derivative. That means we need to differentiate a function twice. How? Let us see. We'll begin questions from the exercise so that it becomes clear to everyone about the second order derivative. So I have the question first. That is, first question I have, that is x square plus 3x plus 2. So let's try to find its second order derivative. Let y is equal to x square plus 3x plus 2. Now dy upon dx is equal to 2x plus 3. Now again differentiate this, so I got 2. Okay, so that is how we try to find the second order derivative. Now let's go for the second question we have. The second question, that is x is power 20. We have x is power 20. So you can say that y is equal to x is power 20. So dy upon dx is equal to 20 x is power 19. Okay. Now again we can differentiate it. So we got 380 into x power 18. Okay. So that is how we able to find the second order derivative. Let's go for the third question now. So now the third question is, now what is the function we have? Let us see. That is x cos x. We have x cos x. Let y is equal to x cos x. Okay. So now we will differentiate it first time. So we got x into differentiation of cos x will be minus sin x. Here I am applying the product rule. Plus cos x into differentiation of x will be 1. Now again differentiate it. So I got here I will apply the product rule. So I will got here x into differentiation of sin x will be cos x plus sin x into differentiation of x will be 1 plus cos x. So if I say minus x cos x plus minus will be there, minus sin x, okay, plus cos x. Okay, so that is how we try to find the second order derivative. Now let's move for the fourth question now. What the fourth question is? Log x. Okay, the function is given is log x. Let y is equal to log x. Okay, now differentiating it again, we got 1 upon x. Now again we differentiate it. So what I got here, minus 1 upon x square. Okay, so that is how we able to differentiate the function twice. That is called the second order derivative. Now let us move to the fourth question. Fourth we have done. So now we'll try to, now let's try to find, they have given the function x cube into log x. So now let us try to differentiate this. First we'll try to differentiate, that is they have given x cube into differentiation of log x will be 1 upon x plus log x into differentiation of x cube will be 3x square. Okay, so this we have. Now we'll try to, now it will be square. So we have x square plus 3x square log x. Now we'll try to differentiate it again. So I got d2y upon dx square is equal to 2x plus, again I will apply here product rule. So I got 3 into x square into log x will be 1 upon x plus we have now log x will leave as it is, will differentiate this. So we got 2x. So we got here 6x log x. So I got this. So I got here 2x plus 3x plus 6x log x. Okay. So I got here 5x plus 6x log x, or I can take x common. So I got 5 plus 6 log x. Okay. So likewise, we try to differentiate a function twice. Now let us try to solve more questions. We have solved till here 5. Now let us move on to the 6th one. Let's try to move on to the 6th question we have. So what the 6th question says is e raised power x sin 5x. Okay, the question is e raised power x sin 5x. So now what we can do here is, let's try to differentiate this. So we got here, let take this function as y, e raised power x sin 5x. So now first we'll differentiate it as, that is e raised power x into differentiation sin x will be cos 5x into 5 minus I have e raised power x sin 5x. So I can take as e raised power x common, and we have 5 cos 5x minus we have sin 5x. Okay, so this is what I got here, dy upon dx. So now we'll try to again differentiate it, that is p2y upon dx square. It will be e raised power x, differentiation of this will be minus 5 sin 5x into 5 minus 5 cos 5x plus differentiation of ex will be ex, and here we have 5 cos 5x minus sin 5x. Okay, so now what we can do here in a very simple way, we'll take it as it is further. So now take it minus sign common, so we have, or we can multiply with it. So we get e raised power x 5 into 5, you got here 25 sin 5x minus e raised power x 5 cos 5x plus e raised power x 5 cos 5x minus e raised power x sin 5x. Okay, so now you can see here it will be reduced. Now we have this, so we can take minus e raised power x common and sin. Okay, we have this, so minus 25 and minus, so it will be, if I take minus sign common, okay, so I got 25 sin 5x plus sin 5x. So I have got here minus e raised power x, we have taken common, so I have 26 sin 5x. Okay, so that is how we try to differentiate the function twice. Okay, now let's try to solve another. We have just solved only 6. Now we'll move on to 7th. Now what the 7th question says, let us see. So the 7th question is e raised to power 6x cos 3x. We have e raised to power 6x cos 3x. This is the seventh question. We have just solved only 6. Now let us try to solve the seventh question here. How? Let us see. We have let y is equal to e raised to power 6x cos 3x. So now you can say dy upon dx is equal to e raised to power 6x. It will be minus 3 sin 3x plus we have 6 e raised to power 6x cos 3x. Okay, we can take ex common here, e raised to power 6x common. So we have e raised to power 6x we have taken common. So we have 6 cos 3x minus 3 sin 3x. Okay, so we have differentiate this function as first time. Now we will differentiate second, that is d2y upon dx square. So what I got here, we'll again try to differentiate this. We'll keep this as it is. First try to differentiate this. So we got here 6 minus sin 3x into 3 minus 3 cos 3x into 3, because the differentiation of sin x will be cos x and the differentiation of cos x will be minus sin x. So we have this. Now plus, we'll try to leave it as a differentiate this. So we got 6 e raised to power 6x and we have this 6 cos 3x minus 3 sin 3x. Okay, now we'll try to take e raised to power 6x common. So we have minus 18 sin 3x minus 9 cos 3x plus 36 cos 3x minus 18 sin 3x. Okay, so what I got here is minus 18 minus 18. So we'll have here minus 36 sin 3x plus we have 25 cos 3x. Okay, so we got this. No, 25 will not be there, it will be 27. Okay, so we have this. If we need to take common something, we can take as 9 e raised to power 6x. We got here minus 4 sin 3x plus 3 cos 3x. Okay, so that is how we try to differentiate a function twice. Let's move on to the 8th numerical we have. Okay, so now what the 8th numerical says, we have tan inverse x. Okay, so let y is equal to, we have tan inverse x. So dy upon dx will be, what will be? Tan inverse x differentiation will be 1 upon 1 plus x square. Okay, so we have this. Now we have the function. So now we'll differentiate it again. We got, that is, if I try to differentiate this 1 plus x square, here I will apply the quotient rule into differentiation of 1 minus 1 into differentiation of this 1 plus x square upon we have 1 plus x square whole square. So I got here differentiation of 1 will be 0. So 0 into 0, 0 into something will be 0, and we have this. So we have minus 2x upon 1 plus x square whole square. So that is how we find the second order derivative. Now we'll move on to the 9th question now. Okay, so what the 9th question says, let us see. What the 9th question is, they have given, and this is log of log x. Okay, let y is equal to log of log x. Okay, so now we'll try to differentiate this. Dy upon dx is equal to differentiation of log x will be 1 upon x into differentiation of log x will be 1 upon x. Okay, so now we'll try to differentiate it again. So I got this 1 upon log x will apply with the, here we'll apply the quotient rule. So we have this, that is x log x. So now x log x into differentiation of 1 minus 1 into differentiation of x of log x. So we have 0, we have, again we'll apply here product rule. So we have x into differentiation of log x will be 1 upon x plus log x into differentiation of x will be this. So I got this minus 1 upon, I have x log x whole square. So I got this 1 plus log x upon x log x whole square. Okay, so that is how we try to differentiate the function. Now let us try to solve the next question we have. Here we will solve the 10th question now. So what the 10th question says? Sin log x. Okay, they have given that y is equal to sin log x. Now we'll differentiate first. So we know that differentiation of sin x will be cos x, but x is log, so we'll have cos of log x into differentiation of log x will be 1 upon x. Now d2y upon dx square will be differentiation of this. So x into differentiation of this will be minus sin log x into 1 upon x minus we have cos log x, because we know that differentiation of x will be 1. So to differentiate this, I have applied the quotient rule, that is u upon v. Now what will happen here? We'll have minus sin log x minus cos log x upon, I have x square. So if I try to solve it, cos log x square. Okay, so that is how we try to differentiate the function twice. Let's move on to the 11th question I have. So what the 11th question says, let us see what the function is given so that we can differentiate it twice. That is the second order derivative. So we have solved 10 numericals. Now we'll try to solve the 11th one. So what the 11th says, if y is equal to 5 cos x minus 3 sin x. Okay, 5 cos x minus 3 sin x. Okay, so we have given the function that is y is equal to 5 cos x minus 3 sin x. What we need to prove is d2y square, we need to prove 2y dx square plus y is equal to 0. Okay, so we need to prove this. So in this first we need to find double derivative. So dy upon dx is equal to minus 5 sin x minus 3 cos x. Again d2y upon dx square we have minus 5 cos x plus 3 sin x. Okay, so now again we'll apply here in this, that is d2y upon dx square, that is LHS which I am applying, plus y. So we have minus 5 cos x plus 3 sin x minus 5 sin x minus 3, no, we need to apply y, that is d2y by dx square, plus we have y, 5 cos x minus 3 sin x. So what I have got here? equal to 0, that is equal to RHS. Okay, so that is how we try to differentiate. Now let us move on to the 12th question now. So what the 12th question says, if y is equal to cos inverse x, okay, if y is equal to cos inverse x, what we need to do is we need to find d2y by dx square in terms of y alone. Okay, so what we can do here is cos y is equal to x here. Now differentiate this, so we got dy upon dx will be minus sin y into dy upon dx. Okay, so again we need to differentiate this, so or I can write this as y. So again need to differentiate. So I got here y2 minus, we have this, that is sin y, plus what it will be minus, so we have y1 minus cos y here. Okay, so what I have here, minus y2 sin y minus y1 cos y, or what we can do here, take the common, minus sign common, so we have y2 sin y plus y1 cos y. Okay, here y2 is d2y by dx square and y1 is dy upon dx. So that is how we try to differentiate the function twice. Let us move to the next question, that is 13th. We have done 12. Now we'll try to solve the 13th. So the 13th question is, what this says is, if y is equal to 3 cos log x plus 4 sin log x. Okay, we need to show this, that is x square y2 plus x y1 plus y is equal to 0. Okay, so what we need to do is, first need to find it dy upon dx. So dy upon dx is equal to minus 3 sin log x upon x plus 4 cos log x upon x. Okay, so we have try to differentiate this, that is y1 is equal to minus 3 sin log x plus 4 cos log x upon x, take this that side, xy1 is equal to minus 3 sin log x plus 4 cos log x. Okay, so we have this xy1 is equal to minus 3 sin log x plus 4 cos log x. So now we have find xy1 here and we have the y also, but first we need to find the dy d2y upon dx square. So we have this, we have, now we have find y1. So now what we can do here, we try to find d2y by dx. So we have y2 is equal to, we'll take that, so x into minus 3 cos log x upon x minus we have 4 cos log x. Okay, no, we'll take this as combined function. No? So we have plus minus 4 sin log x upon x. Okay, so we have this. So now we have this, we have taken x here, differentiate this, so I have found this. Okay, so we have tried to differentiate this function as it is. Okay, if I try to differentiate this, I got minus 3 cos log x into differentiation of log x will be, so it will be x into x here. Okay, so we have this. So what we can do here, leave it as it is, and definitely x will be 1, so I have we have minus plus no, first we'll take the minus here. So we have minus 3 sine log x plus 4 cos log x. Okay, we have this. Okay, upon we have x square. Okay, so x will be reduced by this, so we got here minus 3 cos log x plus 4 sine log x. It will be minus, okay, minus, and we have plus 3 sine log x minus 4 cos log x. So what we have here, we have minus sine log x and we have minus 7 cos log x upon we have x square. Okay, so now we'll try to put this value here. We have x square into this y2 minus 7 cos log x upon we have x square. Okay, and we have plus xy1, we have this plus, now minus 3 sine log x plus 4 cos log x plus y. What is y here? 3 cos log x. We have 3 cos log x plus 4 sine log x. Okay, so if I try to solve this, minus sine log x minus 3 sine log x, so it will be minus 4 sine log x. Okay, I have this, then minus 7 plus 4, we have minus 3 cos log x plus 3 cos log x plus 4 sine log x. So it will be reduced and we got 0. Okay, so that is how we can find the second derivative or the function, and will like prove like this such kind of questions we have. Now let us try to solve the next question we have. So we have just solved 13. Now we'll try to solve 14th. Okay, so we have, now we'll try to solve 14th. So what the 14th question says, let us try to find. 14th question says, now y is equal to nx. Okay, this is given. We have to show that, that is, we need to show y2 minus m plus n y1 plus mny is equal to 0. Okay, so we need to prove this. So let's find first y1. We have y1 is equal to, we have a m e raised power mx plus b n e raised power nx, and y2 we have a m square e raised power mx plus b n square e raised power nx. Okay, so now what we can do here, we'll try to put this value in this. So we got LHS, that is y2 is am square e raised power mx plus bn square e raised power nx minus m plus n. We have y1. What is y1? We have this am e raised power mx plus bn e raised power nx plus mn. What is y? We have a e raised power mx plus b e raised power nx. Okay. So now what we can do, we multiply here. So we got am square e raised power mx plus bn square e raised power nx. We have minus am square e raised power mx minus bmn e raised power nx minus nanm e raised power mx. Then we have minus bn square e raised power nx plus we have amn e raised power mx plus we have bmn e raised power nx. So what we have got here, if we reduce them, am square here we got here with this and bn square. So we have bn square with here. So they will reduce all. So we get here 0. That is how we try to differentiate the function twice. Okay. So now we have the next question to solve, that is 15th one. So now what the 15th question says, let us see. So we have the 15th question. What the 15th question says, let us see. If y is equal to, we have, if y is equal to 500 e raised power 7x plus 600 e raised power minus 7x, we need to show that is y2 is equal to 49y. Okay, so in this also we need to differentiate the function twice. So first we'll find y1, that is 3500 e raised power 7x minus we have here that is 4200 e raised power minus 7x. Again need to differentiate. We got 3500 into 7 e raised power 7x minus plus only 4200 into 7 e raised power minus 7. Okay, so again now I can take this common. What we can take common as, if I try to see 49, I can take common as. So we have 500 e raised power 7x plus we have 600 e raised power minus 7. So we can see here that is value is y. Okay, so that's how we try to differentiate the function twice and we can prove if it is required. Okay, so now let's try to solve the 16th question now. Now the 16th question says, if ey x plus 1 is equal to 1, okay, what do we need to do? We need to show that d2y by dx square is equal to dy upon dx whole square. So what we can do here, try to put it like this. So now what we can do, take log, then differentiate it. So taking log both sides, taking log both sides. So what do we have here? If we take log both sides, log e raised power y is equal to log of 1 upon x plus 1. So we know that it will be y is equal to, taking log of this, now we have log of 1 upon x plus 1. Now differentiate it, we got 1 upon differentiation of x will be 1 upon 1 upon x. So that is, we have the x, so it will be x plus 1. Okay, x plus 1 into differentiation of this will be, if I differentiate this I got x plus 1 whole square, and we have minus 1. So we have minus 1 into, if I differentiate this, I got the 1x plus 1. Okay, so now what we need to prove is, we need to take square of y1, that is square of y1, it will be minus 1 upon x plus 1 whole square, it will be 1 upon x plus 1 whole square. So we have this, and now we have y1. If I take whole square this, I got same. So y1 square will be minus 1 upon x plus 1 whole square, it will be 1 upon x plus 1 whole square. Okay, so that is how we can prove like this. Now let us try to solve next question. Now we have, so now next question we have just solved 16 numericals here. Okay, so now let us try to solve the 17th. What the 17th says, if y is equal to, if y is equal to tan inverse x whole square, so we need to show this. Okay, what we need to show is x square plus 1 whole square, we have x square plus 1 whole square plus 2x x square plus 1 y1 is equal to 2. Okay, now let us try to solve this. Now we'll prove this as, first we have y1 will be 2 into tan inverse x upon 1 plus x square. Okay, so this is what we got here, y1. Now we have the y1 here. Now we'll try to find, that is y1 into 1 plus x square is equal to 2 tan inverse x. Okay, so we have y1 into 1 plus x square, it will be 2 tan inverse x. Now we need to find y2. Okay, so how to find y2? Let us see how we can solve it. We have this function. Now y1 we have, what we can do here, we can easily find y2 here, that is y2 will be 1 plus x square into 2 into differentiation of tan x will be 1 upon 1 plus x square, minus, if we differentiate, now if we differentiate this, that is we need to take tan inverse x common and try to differentiate this. Try to differentiate this, sorry, 1 plus x, so we have 2x. So now upon I have 1 plus x square whole square. So now what I got here, 2 minus 4 tan inverse x upon 1 plus x square whole square. Okay, so now I can put here the value y2 we have, if I take 2 common here, 1 minus 2 tan inverse x upon I have 1 plus x square whole square, we have y2, this is the y2 into this, the 1 plus x square whole square. So it will be reduced by this, plus we have done this, so we have, what we have here, y1 into this one, we'll have 2 tan inverse x, we'll have 2 into 2, 2 into 2, 4x into tan inverse x. Okay, we have this. So now we'll try to find. So now if I take 2 minus 4 tan inverse x plus 4x tan inverse x, so I got 2 here, that is RHS. So that is how we try to differentiate the second order derivative. So if you have any doubt, you can ask, comment and share, and also please like my channel.